Hey, good morning, everybody. This is Mr. Aynesworth, and we're going to get into a little mind map or concept map of how to find the domain of all 6 trig functions. And this is super important because knowing the domain of every function helps you figure out where it's undefined, and that helps you out figuring out where the asymptotes are, because all rational functions that have points where it's undefined have vertical asymptotes, and some of these functions do. And so today we're going to get good at finding the domain and totally understand that, so that when we do graph the reciprocal functions like secant, cosecant, and cotangent, we know where the vertical asymptotes are. They are always where the domain is or the function is undefined. Okay, so let's start off with the two-paired function sine and cosine here. As you guys know, because we've already been through the first 3 here, that sine and cosine don't have any restrictions. Okay, so break out your red pen here, and then let's fill this concept map out together. By the way, you can do this freehand. Just open up a new page in OneNote, or you can go in Canvas and get this page right here where it's all set up for you. But it's much easier just to draw it out. Okay, so pause the video and do that if you need to, and then get started with me. So here we go. So the parent function sine x here does not have any restrictions. Okay, neither does cosine. So I'm going to say no restrictions here, and that means the domain is a set of reals. Okay, no restrictiones. All right, that is why the period. No, I don't want to talk about the period. The domain here is all reals for both of them. Okay, and you already know that because we've done a couple masteries on the first 3 functions. So for both sine and cosine, no restriction. The domain is a set of all reals. Okay. Now tangent, that's not so. Okay. Now we talked about how to define tangent, and that's what I want to start off first. Now tangent is defined to be sine of the angle, so sine of x here, divided by cosine of x. And notice that it's a rational function. And I talked about in the previous lessons here that whenever you have irrational functions and there's division involved, you got to go back to one basic concept from grade school, actually, elementary school. And let's put this in red, and it's very, very simple. Okay, you cannot divide by 0. So you cannot divide by 0. You never could, and you never will be able to, which means cosine x here, the denominator. So the denominator of all these rational functions right here, and I'm talking about the reciprocal functions, secant, cosecant, and cotangent, all the denominators cannot be equal to 0. So that's how we start. Okay, so you say cosine x, the cosine of whatever angle, cannot be equal to 0. So you got to ask yourself, when is cosine equal to 0? Or in other words, cosine of what angle? Because remember, x is an angle here. Okay, the input is an angle. And so think on the unit circle here. In fact, if you want, go grab a unit circle and then put it off to the side in your OneNote. Oh, that might be a good idea if you want a visual. Okay, so since we're digital here, I've done this with you many times before. You just go ahead, grab a unit circle like I'm doing here. Look at this. Look how fast and easy this is. Screenshot it. Okay, like I just did right there. This is the stuff that we do in class all the time, since we are a digital iPad class. And then bring it in. So just copy and delete. Bring it into your OneNote so you can have a visual. So go off to the side, click on text mode, and then boom, paste it in. And there you go. You have a nice handy dandy unit circle here. Okay, so let's just put that off to the side. So notice here, I'll just highlight the areas here, or the angles, where cosine is equal to 0. And so notice that at the top of the unit circle at pi halves, and then 3 pi halves, and then 5 pi halves, and 7 pi halves, and all the multiples of that, or not multiples, multiples of pi halves. No, I can't say multiples. Pi halves plus n pi here, or k pi, where k is an integer. That is where cosine is equal to 0. So let's list that out. So x cannot be equal to here pi halves. Now we're at the top of the unit circle. The bottom of the circle, 3 pi halves, and then back up to the top again, 5 pi halves, back to the bottom, 7 pi halves. And notice right there that we're adding pi every single time. So to get from one angle to the other angle, We're adding pi, and that's because the period of tangent is pi radians, as you guys know. This function has vertical asymptotes at negative pi halves, 3 pi halves. So we've already done the graphing. You guys know that. We proved it in Desmos. And so we have to add multiples of the period. That's what I meant to say earlier. So the way you write this in a fancy notation here is x cannot be equal to pi halves, all right, plus multiples of the period, which we write it as k pi, where k is some integer. And you have to remember, if you have a hard time visualizing integers, I'm talking about 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. Okay, that's what integers are. Okay, and so that is the domain right there. Okay, and believe it or not, that's where all the vertical asymptotes are. So once you know what the domain is, which I listed here, you know where the vertical asymptotes are. Okay, vertical asymptotes. That's where you plot them, guys. So you have to understand the function to understand where the vertical asymptotes are, and then you can graph it easily. Piece of cake, man. All right, and so that's how you approach all three of these other functions. And this right here, this little mind map activity here, is to get you to really fully understand how to find the domain and understand these other functions, because guess what? We got to graph those too. All right, so now let's apply the same idea and to these other functions. Okay, so here we go. So secant of x here can be re-expressed as 1 divided by cosine of x. Look at that. Because secant is a reciprocal of cosine. And as I just said over here, when I analyze tangent here, we can't let that denominator equal to 0. So we're going to say that cosine x here cannot be equal to 0. And that means that x cannot be equal to pi halves, 3 pi halves, here we go again, dot, dot, dot. Okay, or we can say, hey, x cannot be equal to pi halves plus multiples of pi. So, yeah, so plus k pi, there we go. And there is your domain, okay? All right, so there you go, that's it. That's the domain. Can't be any easier than that. Okay, so there we go. Let's try sine. Okay, so now we take the reciprocal of sine. We call that cosecant. Cosecant of x is just defined to be the reciprocal of sine. So we take that and write it as 1 divided by sine x. That's the definition, right? But now the denominator sine x. So here we go. Similar strategy here. Sine x cannot be equal to 0. But we get different angles because the denominator is sine and not cosine. So here, you got to change your thinking a little bit here. So the sine of what angles give you 0? Well, if you go back to the unit circle and you ask yourself, okay, where is sine equal to 0? So let's analyze that. So we're looking at the y coordinates here. So I know that the sine of pi, let's actually start at 0 here. The sine of 0 equals 0. Look at the second y coordinates right there. So let me make a little notation here. So the sine of 0 equals 0. And right here, we get sine of pi equals 0 as well. Okay, and so the sine of 0 is 0. So 0, pi, 2 pi. Again, you can go all the way back around and go 2 pi radians. 3 pi, 4 pi, 5 pi. Okay, multiples of pi. That's where sine is equal to 0. All right, and then you say the angles here, x cannot be equal to those angles because otherwise sine would be equal to 0. And that's a no-no because you can't divide by 0. Or remember, the denominator cannot be equal to 0. And it goes back to elementary school, guys. I don't care what the denominator is. It cannot be equal to 0, as I keep repeating myself, okay? Because I'm trying to drive the point home. You guys got to learn how to think about the functions, and then you can figure out the domain really easily. And you don't have to memorize anything because it's all done by understanding, not by memorization, okay? So x cannot be equal to 0. It cannot be equal to pi. It cannot be equal to 2 pi, 3 pi, and so on, dot, dot, dot. So x cannot be equal to pi plus k pi. Just simply means, you add multiples of pi right here. So k is some integer. All right, and that's the domain of the cosecant function. So again, our end result here is the domain. And again, that's where the vertical asymptotes are going to come in because the function is not defined there. Okie dokie. Next one here. Well, tangent's defined to be sine over cosine, right? Well, cotangent's a reciprocal of tangent. So this one's cosine x divided by sine of x, because cotangent is a reciprocal of the tangent function. Okay, and as I just said earlier here, the denominator cannot be equal to 0, and guess what? That's sine x again. So here, the denominator sine x cannot be equal to 0, which means that x cannot be equal to 0, okay, pi, 2 pi, 3 pi, etc. So x cannot be equal to pi plus k pi, okay, plus multiples of period. You just keep adding pi, obviously. Pi is 2 pi, plus pi is 3 pi, and so on. So, and then you always have to specify k because there's many different types of numbers out there, and then k has to be an integer in this case, like plus or minus 1, plus or minus 2, plus or minus 3, including 0. So 0, plus or minus 1, plus or minus 2, etc. All right, it's not a rational number, k is, and it's not a counting number. It could be negatives too. All right, so just keep that in mind. And so the domain of this function, the cotangent function, is all reals except these values. Okay, so all reals, all right, except, so notice that key word there, 0, pi, 2 pi, and so on. All right, and they're negative. So, well, actually plus or minus there. So there we go. And there is the concept map or the mind map of all 6 trig functions of how you find the domain, which again will help you find the restrictions on each function and help you graph what are called vertical asymptotes of the function. Okay? So what you guys need to do is go ahead and now you do it. You generate this map. Okay? So after you go through this right here, go to a new blank page and try to reproduce it. Try to teach another person, try to teach a classmate. We call that the Feynman technique after Richard Feynman, so the famous physicist back decades ago. He was one of the greatest teachers of all time, not just in physics, but just in general. And if you can be like Feynman and actually teach your classmates, then you can actually know what you're doing. All right, because watching this is one thing, and writing it on your own is another, and teaching it to your classmates is another level too. So if you can do that, then you know what's going on. So be like Feynman, okay? Start practicing and teaching each other to really, really understand what's going on. And I'll see you in my next video. Take care, guys. This is Aynesworth. Bye-bye.